we continue looking at the basics of electricity. This document and other related documents can be found on our website, which I have placed in the video description below. DC parallel circuit. Resistance in a parallel circuit. A parallel circuit is formed when two or more resistances are placed in a circuit side by side. Remember, in a series circuit, they were in line, one after the other. In parallel circuit, they are placed side by side so that the current can flow through more than one path. The illustration shows two resistors placed side by side. So that's R1 and R2. There are two paths of current flow. One path is from negative terminal of the battery. Remember, it's electron flow they're dealing with here. From the negative terminal of the battery through R1, returning to the positive terminal. The second path is from the negative terminal of the battery through R2, returning to the positive terminal of the battery. To determine the total resistance when resistors are of equal value in a parallel circuit, use the following formula. RT, as total resistance, equals value of any one resistor divided by the number of resistors. In the following illustration, there are three 15 ohm resistors. The total resistance is, so you have three of them. The value of any one resistor divided by the number of resistors. So in this case, RT, total resistance, is 15 ohms, which is each divided by 3. So what that means is that if there were 4 of them, total resistance would be 1/4 of each. If there were 5 of them, total resistance would be 1/5 of each, and so on and so forth. But be careful, this considers that the resistances are exactly the same. Now we're looking at the situation where the resistances are not the same. Formula for unequal resistors in a parallel circuit. There are two formulas to determine the total resistance for unequal value of resistors in a parallel circuit. The first formula is used when there are 3 or more resistors. The formula can be extended to any number of resistors. That's this formula. Well, they say when there are 3 or more resistors, but I've found that it also works when there are 2 resistors. So 1 over RT equals 1 over R1 plus 1 over R2 plus 1 over R3, and so on and so forth. In the following illustration, there are 3 resistors, each of different value. The total resistance is, alright, so here 1 over R1, which will be 1 over 5, plus 1 over R2, which is 1/10, plus 1 over R3, which is 1 over 20. Then here you use your mathematical fraction techniques to work this out. So this will be 4/20 plus 2/20 plus 1/20, and then we have 1 over RT is 7/20. We have 4/20 plus 2/20, that's 6/20, plus 1 more 20, that's 7/20. We add the denominator, add the numerators, and you invert both sides of the equation. You find the reciprocal of both sides. RT over 1 is 20 over 7. 20 over 7 is 2.86 when you divide. The second formula is used when there are only 2 resistors. RT is 1 R1 R2 over R1 plus R2. That's product over sum when you have two resistors. In the following illustration, there are two resistors, each of different value. The total resistance is RT is the product over the sum, 5 by 10 over 5 plus 10. RT is 50 over 15, which is 3.3 ohms. So that's the equivalent of 5 ohm and 10 ohm. Now you can try the 1 over 5 plus 1 over 10 and you will see that it will work out. Now, voltage in a parallel circuit. When resistors are placed in parallel across a voltage source, the voltage is the same across each resistor. In the following illustration, 3 resistors are placed in parallel across a 12 volt battery. Each resistor has 12 volts available to it. So you can see here, 12 volt battery, each resistor 12 volts. Current in a parallel circuit. Current flowing through a parallel circuit divides and flows through each branch of the circuit. The total current in a parallel circuit is equal to the sum of the current in each branch. So they all add up to give the total current. The following formula applies to current in a parallel circuit. IT is I1 plus I2 plus I3. They all add up. Current flow with equal value resistors in a parallel circuit. When equal resistances are placed in a parallel circuit, opposition to current flow is the same in each branch. In the following circuit, R1 and R2 are of equal value. If the total current IT is 10 amps, then 5 amp will flow through R1 and 5 amp would flow through R2. You can see it here, 5 amp and 5 amps. That's when the resistances are equal. So total resistance IT is I1 plus I2, which is 5 plus 5, which is 10 amps. Current flow in unequal values of resistors. With unequal values of resistors in a parallel circuit. When unequal value resistors are placed in a parallel circuit, opposition to current flow is not the same in every circuit branch. So you have different resistors now. You have different oppositions to current flow. Now, the smaller resistor will allow more current through it. The bigger resistor will allow smaller current through it. Because the higher the resistance, the lower the current. The lower the resistance, the higher the current. So, current is greater through the path of least resistance. In the following circuit, R1 is 40 ohms and R2 is 20 ohms. Small values of resistance means less opposition to current flow. More current will flow through R2, the smaller resistor, it's 0.6 amps, than R1, the bigger resistor, which is going to be 0.3 amps. So you have 0.3 amps flowing through 40 ohm, but now more amps, 0.6, flowing through the higher resistance, 20 ohms. So the total resistance, the total current is 0.9 amps, because 0.3 plus 0.6 is 0.9 amps. So here they say using Ohm's law, the total current for each circuit can be calculated. Current is the volt, 12 volts, no, 20 volts here you have 120 volts written here, but it should be 12. Their mistake. It should be 12 volts. So the current is volt over resistance, 12 volts over 40, which is 0.3 amps. I2 is E over R2. Current is volt over resistance, which is 12 volts over 20 ohms, which is 0.6 amperes. Alright. Now, total current I1 plus I2 is 0.3 plus 0.6, which is 0.9 amperes. So you see, I1 is 12 over 40, which is 0.3, and I2 is 12 over 20, which is 0.6 amps. So the total current can be calculated by first calculating the total resistance, then applying the formula for Ohm's law. If you use the product over sum, 40 by 20 over 40 plus 20, which is 800 plus 800 over 60, which is 13.333 ohms. And the total current, 12 volt over 13.333, is 0.9 amps. Alright, so we have a review. Total resistance of a parallel circuit that has 420 ohm resistor is, I want you to calculate it and let me know what it is. You can place it in the video description. Alright, RT is the RT for the following circuit is, what is total resistance here? They're asking for RT, the total resistance for this circuit as well. Voltage available to R2 in the following circuit is how many volts? This question says, in a parallel circuit with two resistors of equal value, alright, and a total current flow of 12 amps, the value of current through each resistor is, so whatever the resistance is, you don't need to know, they are equal value. Current is 12 amps. What's the value through each resistor? You should calculate that. In the following circuit, current flow through R1, what is it? And for R2, what is it? Calculate those. Then we have series parallel circuits. We will study the series parallel circuit in a separate video, so I will see you then.